Hi, I'm Dave Klein, and this is the Cymulate cybersecurity broadcast. Today, we're going to talk about cloud security essentials. In the past, we've had several broadcasts that cover security controls from environmental perspectives or application perspectives. We talked about first party and third party. Third party are the controls you buy to protect an environment. First party being things like operating systems and other types of applications or other cloud control things in the past. We've talked to George Nazare, email expert on email. We talked to Tim Savage on identity. We talked to Chuck Sorois on how to prevent hackers from living off the land. Today, we're going to talk to Yoni Leitersdorf about cloud and all the importance of cloud. For those past broadcasts, you can go to our YouTube channel to go see those broadcasts. I'll put a link in the notes section of this video so you can see those as well. But welcome, Yoni. How are you? Tell everyone about yourself.
I'm great. How are you? How are you, Dave?
Awesome.
My name is Yoni. I'm originally from Israel. I live in California now with my wife, 3 kids, and 2 dogs, which you might hear along this broadcast.
Post 2020, it's all good. Post 2020, It's all good. Mine's sleeping under the desk.
Yeah, it's still 2020, isn't it?
It isn't 2020. I thought it was.
Yeah, it still feels like 2020.
Groundhog Day. Yes.
Exactly. Completely. My background is mostly technical. So I started coding at a young age, and then got into cybersecurity in the military in Israel. And then after that, worked for Checkpoint, started my own company. So I've got quite a bit of tech, cyber, and business experience. And here I'm CTO US here in Cymulate.
Very cool. Well, welcome to the broadcast. So let's start with cloud security. One of the biggest things, the fundamental thing, and often this is important, is the cloud responsibility model, right? At the highest level, when people decide to put their workloads in the cloud, they begin with the cloud responsibility model. Why don't you talk about that?
Yeah, sure. So the cloud vendors, they're calling it the shared responsibility model around security. And basically what they're saying is part of this responsibility for security is on us, the cloud vendor, and part of it is on you, the customer. And there's a lot of sense to that in the sense that, the cloud vendors can only protect the things that they control well, and some things they need you to do the job. The challenge that I've seen with many organizations around it is that they don't necessarily know where the line goes. So where is the kind of, AWS, Google, et cetera, where up to where they are responsible versus where the responsibility starts with the customer. And so I've seen sometimes customers kind of not understanding that point and maybe being a bit contentious around it. But really, it is something that is very, very important to understand, because when you are deploying workloads in the cloud, you must understand what is your responsibility from a security perspective and make sure that you're following that and doing what you should be doing as a customer.
What would you say in talking to business leaders, maybe the non-technical? What are some of the biggest mistakes that you see some enterprises think about when they think about the cloud shared responsibility model, and what is their and not their responsibility?
Yep. So the biggest mistake is just using defaults and kind of assuming that the cloud vendor takes care of a lot of the security aspects. So what I've been seeing with a lot of workloads, a lot of uses of enterprises out there, is that they spin up workloads, applications, different bits of code, databases, et cetera. And they're just kind of taking the defaults as is that are available in the cloud environment. And usually those defaults are not secure enough because the cloud vendors opted for ease of use. They said, okay, well, the defaults need to be something that you can spin up in a moment and not security. And so when you go down that path, you very quickly find out that everything you spun up is not secure. And the trouble in the cloud is that once you've spun stuff up, once you have workloads working, especially if they're in production, it's a lot harder to now change things. It's a lot harder to change the architecture of what you built. And you're kind of stuck, and it's gonna take you a while to get out of that. So that's the number one mistake that I've seen. The number two mistake that I've seen is that a lot of organizations treat the cloud as an extension of their on-prem data center. So they say, well, like I have virtualization in my data center, let's say I've got with VMware, so I've got virtualization in my data center. Now I've got virtualization in the cloud, and therefore it's sort of an extension of that. And I'm going to treat it the same. But no, you can't, because there are a lot of different paradigms in the cloud. There are a lot of other concepts that you're not used to from the on-prem world. And also, once it's in the cloud, it does have a bigger attack surface than what it would normally when it's on your on-prem data center, because of how cloud is built. And so coming in with that notion of the cloud as an extension of my data center, just as simple as that, is doomed for failure. So those are the two top mistakes I see organizations do when they're kind of thinking about this stuff. And therefore, if you are spinning up workloads in the cloud, if you are creating applications in the cloud, you need to hire people who understand the cloud, or make sure that your people are well trained on it, because otherwise you're going to make mistakes that are going to cost a lot of money.
I agree with that very much so. And about the security practitioner versus a cloud practitioner, you talk about the need today for purple teaming, for bringing together the cybersecurity staff as well as the cloud staff. It's even more important, because it seems like in some cases the architectures are different, and therefore the security people need more education on how it is different. At the same time, the security people bring their traditional security background and trust but verify kind of background to the mix, and they can rub off on the cloud people as well. I think that's really kind of critical.
Mm-hmm. Yeah. So what you see is that cloud people sort of optimize for speed. So they try to see how fast can I spin things up and get a new application going, and do what the organization needs me to do. Security people optimize for security, and so those two sometimes come in conflict, and the two types of people and the two teams need to learn how to work together, on the one hand to maintain speed as much as possible, but on the other hand to also achieve security, because at the end of the day you are handling customer data in these applications, and you need to make sure that that data is secure. And so, you mentioned purple teaming here. The concept of purple teaming is where you essentially have the cooperation of a blue team and a red team, right? But essentially it's, I'm gonna take two teams in my organization and make sure they work together for the greater good of the organization. And the same thing applies in cloud and security people. You want to take cloud people and security people and have them work together. You want your security people to understand the cloud concepts, and you want your cloud people to think about security and to be very aware of it and make sure that whatever they're building is secure. So this whole concept of having people from different backgrounds and different teams working together for the good of the organization, I think still very, very much applies here, and is very important.
Very much so. And another aspect of cloud that's kind of interesting, I have an anecdote on this one. I worked with one of my customers in the past, and the challenge was they were a mixture of hybrid premises, data centers, clouds, and even vSphere as a service in some situations. And what they did was to cut costs, and also to encourage the various DevOps and application and production teams from ordering new hardware versus taking what they had and optimizing the workloads on the places that they had. They said we're going to hold off any other hardware purchases for the year. And then what happened was they found out that they could take their credit card, and that the expense was I don't want to say a petty expense. Forgive me, I'm not an accountant. I'm a cybersecurity guy. But it was like a petty expense. You use your department credit card and order a VPC. And in this situation, it was multiple vendors, right? So each department had a project. They couldn't get more servers, hardware in-house. So they began using VPCs. And it was the most unusual cloud adoption. But what happened was, eventually, the amount of workloads they had in the clouds were such they were beyond that petty cash or whatever that accounting threshold was. And I was like, oh. So I was working on a project unrelated, and the poor guy I was working with kept getting phone calls. Why are you turning these workloads off? Things like that. And it turned out the problem was this was a huge Phantom IT problem in this enterprise, and they were trying to figure things out. So let's talk about Phantom IT for a bit. What's some of why does this seem to be such a big deal in cloud?
Well,
Even worse,
first of all, First of all, the beauty of people is that driven people, motivated people will figure out how to get the job done, right? So if you as an organization put all kinds of blocks in front of them and saying, like your example here, you're not going to buy any more hardware. So, somebody put that in and was like, thinking it was a smart idea, I'm going to not allow them to put hardware and I'm going to force them to do something. But motivated people are a bit like water. They're going to figure out a way to do what they need to, and they're going to flow in the direction that they need to. At the end of the day, they will figure it out. And so that's where this whole shadow IT, phantom IT problem comes into play, where people are saying, well, I got a job to do, and these guys at IT or whoever it is not going to get in my way, and I'm going to do what I need to do, and I've got a credit card, so I'm going to use that, and I'm going to open an AWS account or GCP or Azure or Oracle or whatever cloud account. I will open an account, I'm going to use it, and I'm going to do my job because I have a goal to meet and I want to make sure I meet my goal and maybe my bonus. And so that's what they're going to do. And in that process, what you actually did by creating these kind of barriers for people is you've pushed them away. And when you've pushed them away, they are no longer working with you. They're no longer partnering with you. They're no longer coordinating with you. And so they set up all kinds of things. And then they set up, like, for example, an S3 bucket with no protections, and they put all of your customer data in there. And then a hacker finds it, and the hacker is very happy, but your organization is not. And so this whole concept of shadow IT is actually caused by IT thinking about things in the wrong way and trying to put these barriers and force people like cattle into a specific path. And people don't work that way. And so instead, I would urge people to think about how to correctly how to partner with people. By the way, are you hearing that?
It's okay. Hey, listen, again, it's 2020, remember?
Yeah, exactly. I can try closing this door to see if it will help. But yeah, this is
no worries.
It's very much.
If it gets loud, I'll let you know. We'll close the door. But and you're so right. And again, and what's funny is this topic comes up again and again and again. We often have very technical broadcasts or ones that are for executives, but on both sides of that those broadcasts, people are talking about get to know the other side even better, and it's important that again everyone works together to make things work out better and stuff like that. Let's talk about the essential things. Let's talk about the essential fundamentals of cloud security. What are some of the things that you see? If you said, in my life, I've seen these 5 things, what would they be?
So if you remember earlier, we talked about defaults. So the first thing is making sure you're not using default, but you're rather using secure configurations. And so part of that could be just by reading the materials provided by the cloud vendors. Part of it could be by consuming tools like CSPM, Cloud Security Posture Management tools, which will help you validate your configuration. So that is the first thing I would get out of the way. It's the making sure I'm not using these insecure defaults, but rather I'm building things securely. Okay. That's the first thing. The second thing is around pulling other security controls into play. So a lot of times organizations we work with already have enterprise grade security controls. Like they'll have an EDR, they'll have firewalls, they'll have web security gateways, email security gateways. They'll have all these technologies in their on-prem and web endpoint environment already in use. And so a lot of these technologies can also apply in the cloud. So for example, if you're using an EDR to protect your endpoints, your workstations, your servers already, you can oftentimes use that same EDR in the cloud, at least for the virtual machines that you're using there. Maybe not for the serverless, but for the virtual machines that you're using there, you can use that EDR. Or if you're using some kind of firewall, let's say next generation firewall in your perimeter environment, you can also a lot of times use that in the cloud and achieve a better level of visibility. So we do see a lot of organizations do that and actually pull some technologies that are not cloud-born into the cloud, but they adapt to the cloud very well. And that actually does help a lot because CSPM only takes you so far, right? CSPM only validates kind of infrastructure level configuration, but you still need to have security controls built into what you're running. And so that's we've seen that as a very important thing. So that's the second one. The third one is training your team and especially your incident response around how to deal with cloud threats. So incident response, identifying threats, etc., is different for cloud versus on-prem because the whole hacker behavior is different. For example, hackers will have a lot more ways in when it's cloud versus not cloud. That's the first thing. But also what they're going to do is going to be different because what they're going to try to do is they're going to try to be covert and maybe not necessarily steal your data, more do things like, crypto mining and things like that. And so their whole way of behaving is going to be different just because of how the cloud is built. So it is important to train your incident response team on that and kind of build this cloud incident response. And that's obviously through practice, right? So you do tabletop exercises, pen testing, et cetera, in order to make sure that your people can respond to such a thing. Now in the cloud, by the way, timeframes are a lot of times shorter. From the moment that a hacker gets in to the moment that they have spun up a new workload and are already wasting your money for crypto mining, that can be 5 minutes, that can be 15 minutes. Also, getting data out of the cloud is also much faster sometimes than on-prem, and so you need to train around that speed of response. So those were the first three things. Now, taking all of that together, what I would highly recommend is actually testing that all of this is working. So using a solution, using all kinds of processes to actually test this stuff. So actually trying to see if you can hack into your cloud environment. And if you can hack into your cloud environment, where can you get to and what can you do? And will your team actually identify that and respond? So there are a lot of exercises that you can do and obviously tools you can use to do that, to make sure that everything I just said is actually put in place correctly and is actually working.
Yeah, and that's critical. We'll get into that in depth in a bit here because I think that's really important to talk about that, the idea of testing in the environment. But before we even get there, I mean, you think about how often, when setting these things up, the need to really do it appropriately. And you talked about best practices on how to set these things up and how often there's a lack of multi-factor authentication, how VPCs and segmentation are often people remove the segmentation for ease of use and stuff like that, but don't realize the damage of that, right? It's almost as if like you had a data center without any segmentation. The cloud is very, very similar and people take away the different ways of reaching it. Also, obviously, you look at today, what hit the news was Uber was hit by a major attack. Unfortunately, it seems to be an 18-year-old who was more interested in seeing that they could do it versus someone like a criminal ransomware gang or a nation state. But literally, it came down to a lack of good authentication and storing their secrets in a document that the person was able to get a hold of and then basically own the environment. Let's talk about the speed to total control in the cloud is much higher, but it's also speed is what you talked about earlier is extremely important how cloud is set up. It seems to be today in a world of Chef, Pup, and Ansible, for a few mouse clicks can basically spin up whole new VPCs, whole new environments, right? There's a need to be able to handle things from that early phases. And it comes into testing, right? So let's talk for a second about what are some things we could do to incorporate testing in those early phases.
Yeah. So first of all, I think we need to understand our adversary. Our adversary is not necessarily, a group of mature hackers from some other country or, a nation state. It could be an 18-year-old, 17-year-old, 16-year-old. I mean, we've seen in the beginning of this year, I think Lapsus is led by a 16-year-old out of England who managed to hack some of the most secure organizations on the planet.
Lapsus, yes.
Yeah. And my daughter is turning 11 next month, so I have high hopes for her, for the police knocking on my door.
Yeah, and folks on the broadcast, knowing Yoni, I know that's going to happen. I know it's going to happen.
Yeah, so
hi, Dad.
Maybe one day FBI knocks on my door and says, "Hey, your daughter's been up to no good." But so I think first of all, and the jokes aside, we need to understand that our adversaries are, various profiles. And our adversaries are using very, very robust tools. Out there you've got Metasploit and Cobalt Strike and all the other ones. And like the tools are a lot easier to use. They're very smart. They're very covert. It's easy for them. It's Google. Hey, Google, stop. It's just the world. It made life so much easier. And then in the cloud, everything is a lot faster than before. And so you must realize that when you're thinking about your adversaries and who you're dealing with. Once you understand your adversary, once you know who you're up against, you can start thinking about what you're going to do to kind of keep them at bay. Because okay, it's an 18-year-old, and maybe in this case they just wanted to prove that they could get in, but the next person is not going to be that person, and they're actually going to cause damage to your business. So obviously you need to take them very seriously. Now, today, MFA is a standard. I don't think any organization out there is saying, oh, no, I don't think I need MFA. No, everybody knows they need MFA. But the trouble, if we go back to what we talked about, the shadow IT, phantom IT, is that the people who don't know that they need to turn on MFA are usually more business people. They don't think about MFA as much. And to them, MFA is a pain in the butt, because every single time they try to log in, now they need to fumble for their phone somewhere and look for a code. So to them, it's an encumbrance. But to security people, MFA is obvious. And even more now, people stop trusting MFA on text messages and MFA on, on your authenticator app, and people have moved to things like YubiKey. But those are security people who understand that. The others don't. So it kind of goes back to what we were talking earlier about security people needing to work with non-security people and make sure that all the security standards are applied, and that they're working in concert, because if they don't do that, it's not gonna work in the end. But yeah, they have to enforce MFA. And in the cloud, talking about defaults, we said earlier, MFA is not on by default. It's just not.
Yeah.
And so you need to be aware that you need to turn it on, and make sure that nobody can turn it off, and also make sure that nobody can create a user without an MFA. So it's just, you're sort of chasing this situation. The right approach, the right people, the right tooling can solve that problem.
And I'd argue in some ways, things are very different, but they're the same, right? And if you look at, for example, I just did an article on EDR not being a silver bullet. Right? There's no silver bullet in cybersecurity. And the biggest thing was I showed them examples of continuous threat exposure management testing, doing offensive testing against environments with ransomware type attacks, and showing that EDR was present, but 50% of the time, if you have excessive privileges, I can pop a PowerShell. I can take advantage of an HTA file, Internet Explorer based, file, which Internet Explorer is not around anymore, but HTA is still in the operating system. Basic authentication for Exchange, totally had, right? And two patch Tuesdays ago, Microsoft said, we're done with basic authentication. We can't protect you in Exchange if you have basic authentication on, right? And I think Azure finally removed basic authentication. I'm not sure about that, or have a sunset for basic authentication. But the base operating systems, in this case, the base VPCs, are not secure enough, and you need to have best practices to know how to do that. Now let's talk about testing. So Gartner came out with a thing called continuous threat exposure management. US CISA said we need corporations out there to start doing continuous offensive testing. So there's understanding in the industry, both from government sector and law enforcement to Gartner, the need to continuous threat exposure management. The idea is it's not enough to have things like cloud security posture management, the things that check the posture. It truly has to be a situation where you use offensive testing. And you talked about how attackers use tools like Cobalt Strike, right? Among others. They actually use pen testing tools, right? To probe and attack and take advantage. And it really has become a point today that it's not just enough to run all your controls and think about best practices. It really is time to do testing on a continuous basis. What are some of the things, Yoni, that you find make continuous testing possible to adopt? What are things that if you were telling people out there, hey, listen, if you were to adopt this, this is what you need to do?
Yeah. So first, I think one important point about continuous testing, you invest all this money in all these security controls, EDRs, next generation firewalls, CSPMs, training of your teams. Organizations are investing a huge amount of money and are having a hard time answering a very simple question: is my investment doing what it should be doing? Am I actually better positioned to deal with hackers than I was when I didn't do that investment, right? And so what Gartner came out with the continuous, the CTEM basically, is in my opinion, very, very, very important. And I think is something that organizations should be adopting as fast as possible, because by the way, my background is in managing security as well. And it would just drive me crazy that I'm making all these investments and I've got no idea if it's doing what it should be doing. And EDRs today, they're great products. They're really good. But if you don't use them correctly, they're not going to do their job. You talked about popping a PowerShell. Any EDR out there is supposed to catch a PowerShell and look at it and say, this doesn't look right. I should stop this. But if you didn't configure your EDR to stop it, it's not going to.
Right.
And then you spent millions of dollars on this EDR and you still got popped, right? And so I think this concept of continuously testing your controls, your processes, your people is vital, and something that every single organization should pick up. Now, when you kind of think about it also from the perspective of cloud, you now have sort of two modes of operation. One is your on-prem environment. Another one is the cloud. There are some parallels. There are some differences. And you need to make sure that you're testing continuously in both of these places. And when I'm saying testing, it starts from the outside in. So actually looking at your attack surface and seeing what a hacker is seeing, right? What web properties do you have? What does your domain look like? What email addresses? What passwords are available out there? Remember, some of these hacks started from somebody going on the darknet and buying passwords. Okay. So are your passwords running around there? Is one of your users using QWER1234 exclamation mark? That's running around the internet. So start from that. Start from looking at what a hacker sees from the outside, because every single hacker worth their salt, before they deploy Cobalt Strike or whatever, they will look from the outside and say, okay, what can I see? Like a good, like a good military operation. So you need to do the same thing, and you need a solution that will start from there. The next phase after that is you need to think about, okay, how do I get in? Now that I have a picture of my environment, what are the ways to get in, and how do I test that? So if I try to get in through the web application, how is my WAF doing? How is my web application doing? If I try to get in through email, you talked about email security in one of the last sessions. What happens if a hacker sends an email to me, to one of my employees? Keep in mind, I've got a lot of people, and some of them are better trained than others, and some of them might open in a phishing email, and some of them might open an attachment, and then it's going to pop up and say, do you want to enable macros? And they're going to hit yes. So you got to test that stuff, because that happens, unfortunately, a lot still in 2022, the year that we're actually in. And so you got to think like an attacker, and you need to have a solution that supports that process. The noise is going to pick up now, so I'm going to close the door for a moment. I'll be right back.
Go for it. I can, yeah. And you're dead right. And the idea is when we think about continuous exposure management, it combines that breach attack simulation. It combines the attack surface management, the vulnerability management, the discovery mechanism, right? The discovery of what's out there, and the phishing training, all into one package. And the key thing is, that sounds overwhelming, but the way that these things work these days is things are automated. They're templates. The vendor updates it for the current threats it sees out there in the environment, and exploits and things like that. New TTPs come out, not just hash values and things like that. And so the way that these solutions work is they combine all these things, but make it automated and easy to run on a continuous basis. So something in the morning, you come in, you look at a screen and say, I get it, right? Oh, I see in the news there's a new vulnerability out there for Exchange. We've already tested, right? The vendor already updated it. It's already tested. So the idea is it becomes something that is able to run consistently and catch all the things, the misconfigurations, right? someone pushes out a new Terraform for a vSphere environment, or something in their VPC in the cloud, and forgets to do multi-factor authentication, or hard codes the authentication, right? All those different kind of things that would cause issues. You're able to test immediately and see that change in risk, which really is kind of critical.
Yeah, there's, if you kind of think about automation, our adversaries have a lot of automation, right?
Yeah.
They're using. Our DevOps teams have a lot of automation around, just like you mentioned, Terraform. Terraform is an amazing automation tool for building environments. So we in the security space need to leverage automation to test our own controls, test our own processes, and also remediate things, right? So, if we do find a gap, remediate it quickly using automation. So it's just leveling up ourselves to get to the level of the ones that we're, playing against, if you think about it.
And using, ironically, some of the same kind of techniques, which is interesting.
Yeah. Exactly. It's ironic, but it's kind of the other side of it's the mirror side, right? So, even if you look at MITRE, so MITRE has defend and has attack, right? Attack framework and defend, and they're basically mirror images. Attack is what a hacker would use. Defend is what a defender would use. And for everyone, they're kind of mirroring one another because, that's how it works.
Absolutely. And talk about the speed of the cloud. The idea is we can take some of these testing things that we do with continuous threat exposure management and bring them into that DevOps cycle.
Mm-hmm.
How can we do that?
So what you do is you continuously employ that. So if you think about it, a good CTEM tool will have the ability to automate it, right? So if you think about DevOps, maybe take a step back for a moment. If you think about DevOps, it's all about automation. It's all about having a pipeline that every single time does the same thing. Very predictable process, very predictable output. How do you achieve that? Automation, whether it's, Terraform that you mentioned earlier, or whether it's using infrastructure like Jenkins and Circle CI, the DevOps tools. And everything revolves around having APIs and being able to automatically interact with systems and get them to do what you need to do. The same thing applies here in CTEM. A good CTEM solution worth their salt will have an API and will allow you to automatically run assessments. So for example, if you're thinking about the DevOps flow, a good CTEM solution would allow you to take, let's say, an agent, throw that in the environment you're about to build, add that agent into your process, run a series of assessments, and only if the assessments come back with a very low score, let's say a very low risk score, only then does the environment actually go into production and gets turned on. That's easy to automate if your CTEM solution supports that.
Correct. I actually think here at Cymulate, we have a Jenkins example that we use of us with Jenkins to test workloads before they go into production and fail or allowed to go forward and stuff like that. So that's a great example. Mm-hmm. Well, it's awesome. Excellent. Well, Yoni, thank you so much for joining me today. This has been very valuable and really appreciate it. We are definitely having you back. We're definitely having you back.
Happy to be here. And thank you very much for having me, Dave. I really enjoyed this.
Thank you, everyone. This is Dave Klein for the Cymulate Cybersecurity Broadcast. See you next time.